Welcome to our Arduino project number 11. This project is all about controlling a servo in Arduino. Controlling a servo is an Arduino project that involves using an Arduino board to precisely control the position or angle of a servo motor. This is commonly used in projects like robotics, automations, and interactive systems. Learning this skill offers several benefits. It introduces us to fundamental concepts in robotics and provides hands-on experience with both hardware and software. To start the project, here are the materials we are going to need. A microservo 9G male-to-male jumper cables, a 10K potentiometer, a breadboard, and finally, an Arduino. To start, let's begin by bringing out the servo itself. As we can see, the servo has three wires, a red, a brown, and a yellow. Let's begin by connecting the red wire to the 5V output on the Arduino. Next, let's go ahead and connect the brown wire to any of the GND slots in our Arduino. After this is the yellow wire. This one is supposed to be connected to any of the digital pins of our Arduino. It could be any pin as long as we make sure that this is what we're going to set on the codes later. Now, let's move on to the potentiometer and let's place it on our breadboard. Bring out one of the male-to-male cables and connect it to one of the sides of the potentiometer and connect its other end to one of the 5 slots of the Arduino. Next, bring out another cable, connect it on the potentiometer and connect the other side on the GND slot of our Arduino. And finally, bring out another jumper cable, connect it to the middle slot of the potentiometer and connect its other side to the analog pin A0 of our Arduino board.
So in the hashtag include server.h, this line includes the server library, which provides a function for controlling servo motors, like telling a program to use servo library capabilities. Also, before using the server.h, download the installation first on the library and use the servo, that's the name. And in the next line is the server of my server. This line declares a server object named my server, like creating a variable to represent my servo motor or your servo motor. And in the int pos equals 0 semicolon declares an integer variable pos and initialize it into 0. Pos will be used to store a value for controlling the server position. And in the int val semicolon declares another integer variable val without initializing it. Val will be used to store the value read from the analog input. So in the point setup function is a special function in Arduino, and the line that only one in Arduino is my servo that attach open and close parenthesis 9 semicolon. Inside the setup function, my servo that attaches the my servo object to pin 9 means that the servo motor is connected to pin 9 on the Arduino board. So in the loop function, there's a line called val equals analog read pos. This reads an analog value from an input which is determined by the pos, and like measuring an analog signal at a specific pin. And the next line is also the val equals map open and close parentheses bam 0 10 23 0 179. This takes an analog value ranging from 0 to 10,023 read in the previous step and maps it to the new value ranging from 0 to 179. It is used to scale the input value to the range that the servo motor understands. It's also to 0 to 179 degrees or 0 to 180 degrees. And in the next line, the my servo that write open and close parenthesis val semicolon. This line writes the map value to the my servo object, controls the position of the servo motor. It sets the value or the servo motor position based on the map value. And then on the last line called the delay, open and close parenthesis P15, this line introduces the a 15 milliseconds delay, which can help slow down the servo movement and make it smoother. And that the delay is applied before the loop function repeats.